So the Venn diagram shows the probabilities associated with 4 events, A, B, C and D. And part A says we need to write down any pair of mutually exclusive events from A, B, C and D. So firstly, we're going to define mutually exclusive. So we say event 1 and event 2 are mutually exclusive if they can't happen at the same time. So we can use the Venn diagram up here to work out which out of A, B, C and D are mutually exclusive by looking at where there's no intersection. So for example, A and B aren't mutually exclusive because they intersect here, so they could happen at the same time. Because this here is a probability of A and B. However, look at this, A and C are mutually exclusive because there's no overlapping part, so they can't happen at the same time. So one of the things we can write down is A and C. Okay, so D and C don't overlap at all, so we can write down those as well. Or also D and B don't overlap at all either, so we could also have that. And we'll get 1 mark in the mark scheme for any of those pairs. So we'd only need one of these to get the mark. So moving on, we're now given that the probability of B is 0.4. And now we need to find the value of P, and this is for 1 mark. So looking up at the diagram here, we've got the probability of B, so the probability of all of this is 0.4. And the probabilities that make up B are 0.24, 0.07 and P. And given that the probability of B is 0.4, we know that 0.24 plus 0.07 plus P equals 0.4. Then rearranging that, we can say, okay, so then P equals 0.4 minus 0.24 minus 0.07, which gives us 0.09 as the final answer. So we just get 1 mark for getting the correct answer of 0.09. So moving on to part C now, we're given that A and B are independent. And part C says we need to find the value of Q. This is for 2 marks. So we can use the fact that if A and B are independent, the probability of A and B is the probability of A multiplied by the probability of B. And because we know it says in the question that A and B are independent, we know that this must be true. So we know the probability of A and B. And look up at the Venn diagram here and we see, okay, so here we've got A, here we've got B. So the probability of A and B is this part here, so 0.24. And we know the probability of B is 0.4 because we were told that previously. Therefore, we can say, okay, so 0.24 is going to equal the probability of A multiplied by the probability of B, which is 0.4. So the probability of A equals 0.24 divided by 0.4, which equals 0.6. And then from that, okay, so we now need to work out what Q is. So the probability of A is going to be 0.24 plus 0.16 plus Q. And we know the probability of A equals 0.6. So we could then say that we know that 0.24 plus 0.16 plus Q must equal 0.6. So then it will follow that Q equals 0.6. Take away 0.24. Take away 0.16. So then Q will equal 0.20. And that is the final answer there. So looking where we get the marks, we get 1 mark for this line here. And then we get the second and final mark for the value of Q. So now we're given further that the probability of not B, given that C, equals 0.64. And part D says we need to find, firstly, the value of R, and then the value of S. And this is for 4 marks. So referencing the formula for conditional probability in the formula booklet, we can write out that the probability of not B, given that C, is the probability of the intersection between C and not B, all over the probability of C. So we want to see what this equals. So we've got the probability of C intersection not B. So we're going to look at the diagram and see if we can work that out. So what we're going to be looking at is this area here. So as you can see, we've got C here, and it's where it intersects not B. So not B is anything that's not this area here. Well, the bit where not B and C intersect is this area here. And we see the probability of that is just R. So we can say, okay, so this is going to be R, all divided by. Now we've got the probability of C. And the probability of C here is just going to be P plus R. We know up here that this equals 0.64. So we say, okay then, so therefore 0.64 equals R all divided by P plus R. And in the previous part we found out that P equals 0.09, we got that 0.64 equals R all divided by 0.09 plus R. So this is great. To work out the value of r, we just need to rearrange this and make r the subject. So first, if I multiply through by the denominator, we're at 0.64 multiplied by 0.09 plus r is going to equal r. So we're then going to have, if we multiply out these brackets, we're going to have 0.64 multiplied by 0.09, which is 0.0576. Then multiplying through the 0.64 and the r, we have plus 0.64r, and that equals r. So from that, if we take away 0.64r from both sides, we're going to get the 0.36r equals 0.0576. And lastly, dividing through by 0.36, we're going to get the r equals 0.16. Great, so now we've done the first part of D, we need to look at the second part as saying we need to find the value of S. We can use the fact that the sum of the probabilities here is going to equal 1. The sum of all the probabilities inside A, B, C and D here, plus S here, which is outside, is going to equal 1. And we could write this in a couple of different ways, but we know the value of the probability of B because we've given it here. So we say, okay, so we're going to have 0.4 plus. So we've already catered for all of this. So we're going to have to add r to cater for this part here. And we know that r is 0.16. Then what we've got left, okay, so we've got left this part here. So that's 0.16 plus q. And because q is 0.20, we have 0.16 plus 0.20, which is going to be 0.36. And then lastly, we've got s, so it's just going to be add s equals 1. So rearranging that, we're going to have s equals 1 minus 0.4 minus 0.16 minus 0.36. So therefore s equals 0.08. And that is the final answer. So in this question we get 1 mark for this line here, so working out that we can write it as r all over p plus r. And then we get a second mark for getting down to r equals 0.16. We get a third mark for realising in this part that the sum of probabilities equals 1. And then the final and fourth mark for getting down to s equals 0.08. A sample of 15 days is taken from the large data set for Perth in June and July in 1987. The scatter diagram in figure 1 displays the values of 2 of the variables for these 15 days. And part A says we need to describe the correlation for 1 mark. Okay, so look at this, we can see, okay, so the correlation goes this way. So the answer is that it's a negative correlation. If it went this way, it would be positive, however, because it goes this way, you know it's negative correlation. Now moving on to the next part, the variable x is the daily mean temperature measured in degrees. And part B says, using your knowledge of the large data set, first part we need to suggest which variable is on the y-axis, and the second part we need to state the units for this. So now thinking about the large data set, there are a number of different variables. We need to try and narrow it down and work out which one it could be referring to. So we're told on the x-axis there's daily mean temperature, and we worked out in part A that there's a negative correlation. So we need to think about what variables from the large data set could go on the y-axis, and it would need to satisfy that when the daily mean temperature is increasing, that this variable on the y-axis will be decreasing. So there needs to be a negative correlation between the daily mean temperature and the variable that we choose. And thinking to the large data set, there are 2 options that we could choose from. Firstly, we could say rainfall, or alternatively, we could say pressure. So either of these would make sense, look at the data here. Because through studying the data in the large data set, we can see there's a negative correlation between daily mean temperature and either of these variables. And stating units for this, I'm going to say, okay, so for rainfall, we would have millimeters. And for pressure, we could have any of these units. So we just need to write down one of them to get the mark. And so for questions like this, there's not really a way to work out what the units are in the exam, for example. It's just something you need to learn. So it's worth going through the large data set and learning what the different variables are and the units and things like that in case questions like this come up in the exam. So looking back up, we see, okay, so we get 1 mark for saying it's a negative correlation. Then we get 1 mark for either rainfall or pressure. And then we get 1 mark for the correct corresponding unit. So now we see that STAB believes that there is a correlation between daily total sunshine and daily maximum relative humidity at Heathrow. He calculates the product moment correlation coefficient between these 2 variables for a random sample of 30 days and obtains the fact that is minus 0.377. Part C says we need to carry out a suitable test to investigate STAB's belief at 5% significance level, stating clearly our hypothesis and our critical value. This for 3 marks. So firstly, what we're going to do, we're going to let ρ be the population correlation coefficient. Now we're going to state our hypothesis. So we're going to say our null hypothesis, so H0, is that ρ equals 0. And our alternative hypotheses, so H1, is that ρ doesn't equal 0. Because essentially this links back to the first line here. So saying staff believes there is a correlation between daily total sunshine and daily maximum relief humidity at Heathrow. So we're saying, okay, our null hypothesis is that there isn't any correlation, and our alternative hypothesis is that there is. Now what I've got here is a snippet of the table in the formula booklet, and we're going to use this to work out the critical value. But first we're going to write down the information we know. So we know that it's a random sample of 30 days, so n is going to equal 30, and the significance level equals 5%. However, because it's a two-tailed test, we need to divide that by 2. And we know it's a two-tailed test because by looking at our alternative hypothesis, we've got this doesn't equals here. So it's not greater than or less than, it doesn't equals. So it could be greater than or less than, so it's two-tailed. So using this information here, we can work out the critical value. So going across, okay, so we're going to be in this column here, and going down to a sample size of 30. We're going to meet in the middle here at 0.3610. So now I'm going to draw out a little line here to help visualize it. We've got a 0 in the middle, we've got 1 in the top, and we've got -1 here. Because the critical value we've got here was 0.3610. So, okay, so here, just really roughly, we're going to have 0.3610. However, because it's a two-tailed test, we're now going to need to add the critical value over this side as well. We've got -0.3610. So our critical region, because it's a two-tailed test, is going to be this area here, or this area here. We need to see whether we fall into that critical region. So looking back up at the question, we can see that the product moment correlation coefficient is -0.377. You see, so that falls in here. So we're in the critical region. So, okay, so our critical value is this, -0.3610. And because so -0.377 is less than our critical value, which is -0.3610, it lies within the critical region. So therefore we can say it's a significant result, and there is evidence of a correlation between daily total sunshine and daily maximum relative humidity. So looking through, we get 1 mark for stating our hypotheses here, we get a second mark for the critical value, and the final mark for all of this conclusion here. And lastly, on a random day at Heathrow, the daily maximum relative humidity was 97%. And part D says we need to comment on the number of hours of sunshine you would expect on that day, giving a reason for your answer. Okay, so think about this for a second. In the previous part, we worked out that there's evidence that there is correlation. And we see here, because the R value is less than 0, is negative, it suggests a negative correlation. So this means if one of them is high, the other one's likely to be low. So here we see that the daily maximum relative humidity is really high, it's 97%. So this means it's likely, because we can see up here, there's evidence of a negative correlation. And the numbers of hours of sunshine you'd expect on that day is going to be lower. So to sort of succinctly say that, we could say humidity is high, there is evidence of correlation, and R is less than 0. So essentially it's saying the evidence is that there's negative correlation. So we'd expect a lower than average amount of sunshine, specifically at Heathrow. You get 1 mark for a statement like this, so something along those lines. So each member of a group of 27 people was timed when completing a puzzle. The time taken X minutes for each member of the group was recorded, and these times are summarised in the following box and whisker plot. Part A says we need to find the range of the times, and this is for 1 mark. So to find the range of the times, what we're going to do is the highest value take away the lowest value, so the difference between them. And this is irrespective of whether we consider an outlier or not. So for example, if we look up at the box and whisker plot up here, we're going to ignore whether it's included in this part here, or one of these points out here. All we're going to do is take the highest value and subtract the lowest value from that. So up here we've got the highest value, which is up here. If we try and work out what point it is, so if we've got 60 here, then we're going to have 65 at this point here. So it's going to be 66, 67, 68. So this point here is 68, which is the highest value. And now we need to find the lowest value, and that's going to be the value here. So we know this one's 5. We're going to go 6, 7. So this is 7 here. So for the range, we're going to do 68, subtract 7, which gives us 61, and that is the final answer for 1 mark. Now for part B, we're doing something similar, but this time we're finding the interquartile range. Now the interquartile range is the difference between the upper quartile and the lower quartile. So the upper quartile, subtracting from that, the lower quartile. And here we're going to have a look at the box and whisker plot up here. And this line up here is known as the upper quartile, and this is the lower quartile. So these are the two values we need to find the difference between. So first we're going to work out what this value is. So if I label it here, okay, so we've got 20 here, 30 here, and this is halfway, and it equals 25. And this part here is the lower quartile, and we see, okay, so we've got 10 here, this is 15, it's 1 before 15, and so it's going to be 14. So we've got the lower quartile equals 14. So then coming back down here to work out the interquartile range, 25, I'm going to subtract from that 14, which gives us 11, getting us another mark. Now for the next part, we're given some summary statistics. We're told that for 27 people, the summation of x is 607.5, the summation of x squared is 17,623.25. And part C says we need to calculate the mean time taken to complete the puzzle. And this is for 1 mark. Okay, so we've got the mean, and I'm going to represent that with the symbol here. We're going to say x bar to represent the mean. And the mean is everything added up divided by how many individual things there are. But we've actually got that data here, because if we look back up in the question, we see, okay, so we've got data for time taken in x minutes. So here, when they talk about the summation of x, this is essentially everything added up. So we've got 607.5, and we're going to divide that by how many things there are. So in this case, there are 27 people, which means there are 27 times. So essentially what we've done is we've got all the times added up together, which is 607.5, and we're going to divide that by how many times there are. And because there are 27 people, it means there are 27 different times. If we write this out in the calculator, that gives us 22.5, and we get 1 mark for getting the correct final answer. Now part D says we need to calculate the standard deviation of the times taken to complete the puzzle. And luckily we've got a formula here for the standard deviation. So this symbol represents the standard deviation. And the standard deviation is the square root of the summation of x squared, which is great because we're given that in the question, divided by n, and subtracting from that x bar, so the mean. And that's also great because we just worked that out, all squared. So we're going to do that to work out what the standard deviation is. And then here we've got a square root. We've got the summation of x squared. Well, we're given that up here. So I'm just going to write that in. And we're going to divide that by n. So in this case, n represents the number of things. So in this case, the number of different times recorded. And we worked out here that that's 27. So n is 27, so we're going to divide here by 27. Then we're going to subtract from that x bar squared. So we worked out here that's 22.5. We need to be really careful here and look at the brackets here, because we're going to square x bar and then we're going to subtract it. So it's important to do it that way around. So I'm going to write the brackets in here so it's still clear. So subtracting, and we're going to do this first. We've got 22.5 all squared. That's brilliant. I'm going to put that into the calculator, which gives us 12.10218 ... Now I'm going to round that to 1 decimal place and say that's okay, so that's 12.1 to 1 decimal place. And in this question we get 1 mark here. So if we get up to this part, so subbing in the values in, and then we get a second mark over here for getting all the way to the correct standard deviation. So next it says Taruni defines an outlier as a value more than 3 standard deviations above the mean. Part E says we need to state how many outliers Taruni will say there are in these data, giving a reason for your answer. And this is for 1 mark. So I'm going to focus in on this bit here where it says an outlier is defined as a value more than 3 standard deviations above the mean. So I'm going to write that a bit more mathematically here. I'm going to say, I'm going to use our symbol x bar that we did earlier for the mean, and say more than 3 standard deviations above the mean. So I'm going to add 3, and again use our symbol for our standard deviation. And I'm going to work out what that is. So we've got the mean as 22.5. And we're going to add 3, multiply our standard deviation, which we worked out previously, is 12.10218 ... And I'm going to put that into the calculator to see what we get. And that gives us 58.8, if I round it to 1 decimal place. So now we need to think about the core of the question. We need to state how many outliers Taruni would say there are in these data. So an outlier will be considered anything that is above 58.8. So I'm going to look back up to the diagram at the top, and we're going to find 58.8. So we've got 55, 6, 7, 8, anything around here. So this line is approximately 58.8. So we say, so therefore anything in this region is going to be classed as an outlier. So we're just kind of looking in the region and we see there's only 1 point in here. So all we have to say here is that therefore there's only 1 outlier. And doing that we'll get 1 mark. So taking a look at the next part, we see Adam and Beth also completed the puzzle in A minutes and B minutes respectively, where A is greater than B. When their times were included with the data of the other 27 people, the median time increases, however the mean time doesn't change. Part F says we suggest a possible value for A and possible value for B, explaining how your values satisfy the above conditions. So firstly, the fact that the median increases implies that both values must be greater than 20. And we can see this by referring back to the diagram at the top. So we can see here the median is 20. And if we have one value that's greater than 20 and one value that's less than 20, well, then the median is going to stay the same, because it's sort of the middle number when you line all of them up. So it wouldn't make a difference. If you have both the values less than 20, then the median will go down. So you need both of them above 20, which means the median goes up. Okay, so now we dealt with the first bullet point here. We're going to have a look at the second bullet point, so that the mean time does not change. So we're going to use a variable. I'm going to say y. We're going to let y be the new total sum of times. So essentially, the sum of the times when we're including the new values, so A minutes and B minutes, within that sum of times. So when we do that, we're going to have y here. We're going to divide that by, and now because we had 27 before and we're adding 2 more times in, it's going to be 29. So this is how you work out the mean, because we've got the sum of everything divided by how many there are. But we know that that doesn't change. We're going to set that equal to 22.5. So then from that, if we multiply both sides by 29, we can say that y equals 652.5. So continuing the work up here, we've got that the new total sum of times is 652.5. And what I'm going to do is I'm going to subtract the old total from that, because then we'll know what the sum of the new times are going to be, because they're going to be making up the difference between the old sum and the new sum. So we've got the new sum, which is 652.5, and we're going to subtract from that 607.5, which we know is the old sum from part B. And putting that into the calculator, we get that the difference is 45. So therefore, what we conclude from that is that A plus B is going to have to equal 45. Okay, so I've just summarised everything we've worked out so far in this little box here. So we've got A plus B equals 45. A is greater than 20, B is greater than 20. And from in the question, it tells us that A is greater than B. Now we just need to find some possible values for A and B that could satisfy this. And there are a variety of different values you could have, so you can have a think about that. But the ones I've gone for is A is to be 24 and B to be 21. Because we know if we add these together, we'll get 45. They're both greater than 20, and A is greater than B. And looking through to see where we'll get the marks, we get 1 mark here for this line here. So working out that both values must be greater than 20. We get another mark for realising that A plus B is going to equal 45. And we get a final mark for writing down possible values for A and B. So lastly, we're going to look at part G, which says, without carrying out any further calculations, we need to explain why the standard deviation of all 29 times will be lower than your answer to part D. And this is for 1 mark. So if we have a think about this, we know that the mean from earlier on in one of the earlier parts, x bar, is 22.5. And we know as well from the previous part that the standard deviation is 12.1. So I'm going to do 22.5 plus 12.1, which gives us 34.6. And 22.5 minus 12.1, which gives us 10.4. Now if we have a think about this, if we look at these conditions, so A plus B equals 45, A and B have to be greater than 20, and A has to be greater than B. We know it's not going to be possible to find a value of A and a value of B that satisfy these conditions and greater than 34.6 or less than 10.4. If it was greater than 34.6, it would be more than 1 standard deviation away from the mean. Or if it was less than 10.4, it would also be more than 1 standard deviation away from the mean. But because of these conditions, it's going to have to be between 10.4 and 34.6. So basically it boils down to saying that both of the values A and B are going to definitely be within 1 standard deviation of the mean. Now the standard deviation measures the spread of the values. So if the values were outside of 1 standard deviation from the mean, then the standard deviation will be higher because the values will be more spread out. However, since we know they're going to be within 1 standard deviation of the mean, the standard deviation is actually going to be lower because the values are going to be less spread out. So essentially that's what the reasoning behind all of it. So I'm just going to write that out in sort of a succinct way that you need to write in order to get the marks. So I've written that both values will be less than 1 standard deviation from the mean. So the standard deviation of all values will be smaller. So the discrete random variable D has the following probability distribution, where K is a constant. Part A says we need to show that the value of k is 600 over 137. And this is for 2 marks. So we're going to have a look at the probability distribution here. Now the thing that we're going to use to work out the value of k is the fact that if we add up all these probabilities here, we're going to get 1. And the reason for that is because in this probability distribution, these are the only options we got. We got 10, 20, 30, 40 and 50. And altogether it's going to be 100%. Because as these are the only options, you're definitely going to get one of these. So if we add up all of their probabilities, we know it's going to equal 1. So what we're going to do is we're going to write that down here. So for part A, we got k over 10 plus k over 20 plus k over 30 plus k over 40 plus k over 50. And like we said a second ago, that's going to equal 1. And what's great is we've now got an equation, so we can just solve that for k. So I'm going to add up all of the left-hand side using the calculator. And doing that, we're going to get 137k over 600. And that equals 1. Now if we divide both sides by 137 over 600, we're going to get the k equals 600 divided by 137 as needed. For this question you get 1 mark for this line here, and then 1 mark for the final concluding line down here. So now part B says the random variables d1 and d2 are independent and each have the same distribution as d. And we need to find the probability that d1 plus d2 equals 80. Giving our answer to 3 significant figures, and this question is for 3 marks. Okay, so we're going to refer back to the distribution at the top. And when you think about different ways we could have d1 plus d2 equaling 80. So the first thing that jumps out to me is we've got 40 here, so we could have 40 plus 40. And the only other option we've got is 50 and 30. So we're going to write down the options here. We could have 40 plus 40 equals 80, or we could have 50 plus 30 equaling 80. Now we need to write down all the possible cases. So we're working with d1 and d2. So one of the cases we could have d1 equals 40, and then also d2 equals 40. And the next case we have, okay, so we're now going to refer to the 50 plus 30 equals 80 bit here. We have d1 equals 50 and d2 equals 30. However, we've got another case that we can extract from this. We say, okay, so this time we're going to say that d1 equals 30 and d2 equals 50. And those are all the possible cases we've got for saying that d1 plus d2 equals 80. So now what we're going to do is evaluate the probability that d1 plus d2 equals 80. I'm going to write here just a little note that for and, so when we say and, we're going to use multiplication, and for or, we're going to use addition. So our first case to get d1 plus d2 equals 80, we're going to have the probability of d1 being 40. And so if we look back up to our distribution at the top, we've got, okay, for 40, the probability is k over 40. And actually we notice a pattern. For 10, it's k over 10, 20, it's k over 20. So we can work with that quite easily. So for 40, the probability is k over 40. So we're going to have k over 40. We need d1 to be 40 and d2. And because it's and, we're going to multiply. So multiply by k over 40 again. So that's one case. But now we're going to say or. So we can have this or. So I'm going to add. And we've got the second case. So d1 being 50 and d2 being 30. Okay, so if you remember from earlier, it's just so going to be k over 50. And we're going to have and, so multiply k over 30. And the final case, so or, it could be this case. We've got d1 being 30 and d2 being 50. So k over 30 multiplied by k over 50. So I'm going to simplify that a bit. So we're going to have k squared over 40 times 40. So 1,600. And adding to that, we're going to have k squared over 50 times 30. So 1,500. And lastly, we're going to add again. We're going to have k times k, so k squared, over 50 times 30 again, so 1,500. And we can evaluate that on our calculator, and we get 47 k squared, all divided by 24,000. Now, but we know the value of k from part A. We know that is 600 over 137. It's going to equal 47 multiplied by 600 over 137. Squared, all divided by 24,000. I'm putting that into the calculator. So I get 0.0375619 ... However, in the question it said 3 significant figures. So we're going to get 0.0376 to 3 significant figures. So we got our first mark here for working out all the cases that we could have. We get our second mark here for this line here, and our final mark for getting down to the correct answer to 3 significant figures. So lastly, look at part C. We see the value obtained D is the common difference of an arithmetic sequence. First 4 terms of this arithmetic sequence are the angles measured in degrees of the quadrilateral Q. I mean to find the exact probability that the smallest angle of Q is more than 50 degrees, and this is for 5 marks. Okay, so I'm going to define some stuff. So in our arithmetic sequence, I'm going to let A be the first term in the sequence. And we already know in the question it says that D is the common difference. And we're talking about the first 4 terms in the sequence. So the angles that they're talking about being the first 4 terms in the sequence, we're going to start with A being the first term. And because we know the common difference, we can just say, okay, that's A plus D. And now the next term is going to be A plus D plus D. So we can simplify that to A plus 2D. And lastly, following the same pattern, it's going to be A plus 3D. So we've got a key bit of information that we need to remember, that the interior angles in a quadrilateral add to 360 degrees. So we can use this to add these together and say, okay, so all these angles added together are going to equal 360 degrees. So we've got A plus A plus D plus A plus 2D plus A plus 3D. That's going to equal 360 degrees. Now we can simplify this a bit. So we've got 1, 2, 3, 4 A's. So 4A. And we've got 1D plus 2 plus 3. It's going to be 6D. That still equals 360 degrees. We simplify this further if we divide both sides by 2. Say, okay, so 2A plus 3D equals 180. Now, similar to the previous part in part B, we need to think about the different combinations we could have. And again, we're going to refer back up to the probability distribution up here, which gives all the possibilities of D. So D could be 10, 20, 30, 40, or 50. So that's what we're working with. In the question said we need to look for the probability when the smallest angle of Q is more than 50. Well, if we have a look here, we've got all our angles, A plus D, A plus 2D, A plus 3D. The smallest angle here is going to be A, because each one after that we're going to add something onto it. So our condition, we can simplify it to say, okay, so A has to be greater than 50. Then we're going to look at the possible cases. So A could be anything, but D could only be 10, 20, 30, 40, or 50, as in the distribution at the top. So if we had D to equal 10, we'd have 10 times 3, so 30. And then if we do 180 minus 30, so we've got 2A equals 150, and then we're going to divide by 2. We're going to have 75. So here we could have A is 75, so that works out with our condition, because A is greater than 50, and D is one of the possibilities from the probability distribution above. Now I'm going to try D equals 20. So if we sub 20 into here, we're going to have 3 times 20, which is 60. If we do 180 minus 60, we get 120, and dividing that by 2, we get 60. Or another possible case, we're going to have D equals 20, and when that happens, A is going to be 60. And again, that meets our condition of A being greater than 50. Now the next thing we've got to try is D equals 30, so we're going to sub 30 in here. So we've got 3 times 30, being 90, 180 minus 90, being 90 again, and dividing that by 2, we get 45. And 45 is less than 50, so it doesn't match our condition. And I'm actually going to stop trying the cases here, because as the value of D gets bigger, we know that the value of A is just going to get smaller and smaller. So as when D equals 30 doesn't meet the condition, D equals 40 or D equals 50 won't either. So again, referring to the question, we need to find the exact probability that the smallest angle of Q is more than 50. And that is the probability of D equaling 10 or D equaling 20, as we worked out here. So referring back up to the distribution, it tells us that we're going to have probability of D equaling 10 is K over 10. And for 20, it's K over 20. And because it's or, we're going to add it. And that gives us 3K over 20. And since we've used this before, K equals 600 over 137. I'm going to sub that in the calculator. So we've got 3 multiplied by 600 over 137, all divided by 20. And that will give us 90 over 137. And this right here is our final probability. So looking through to see where we get the 5 marks. We get 1 mark here for identifying the angles. We get another mark for identifying that if we add them all up, we're going to get 360 because it's all the angles in a quadrilateral. We're going to get another mark for simplifying it down to this form. We get another mark for the cases here, and a final mark here for the correct probability. A health centre claims that the time a doctor spends with a patient can be modelled by a normal distribution, with a mean of 10 minutes and a standard deviation of 4 minutes. Part A says we need to use this model to find the probability that the time spent with a randomly selected patient is more than 15 minutes. And this is for 1 mark. So firstly, we're going to start off by defining our random variable. So we're just going to say x. We're going to let x equal the time spent. And then so in the question, we're trying to find the probability that the time spent with the randomly selected patient is more than 15 minutes. So writing this using our random variable, we've got the probability of x being greater than 15. And that's all we want to work out, so we need to calculate this. And we've been told that the model they're using is a normal model. So we're going to say x, our random variable, is modelled by a normal distribution. And we've got a mean of 10, it says in the question, and a standard deviation of 4. So we put 4 here. And then we write it like this, so 4 squared. So now we've got all that, we've got all the information we need to put this into the calculator. So we're going to go into statistics mode into our calculator and go to normal CD. And then we're going to put in the data we've got. So we're going to have a lower, and in this case our lower is going to be 15, so we want everything greater than 15. So the lower is 15. Then for the upper, we're going to put a really big number, so I'm going to put 1,000. Then we've got mu and sigma, so mu is going to be 10, because that's our mean, and sigma is the standard deviation, so that's going to be 4. We're going to press equals and see what we get. So we get that the probability is 0.105649 ... It keeps it going. So I'm going to say that's equal to 0.106. to 3 decimal places, and that's all we need to do for part A. So we just get a 1 mark here for getting the correct probability. Now part B says some patients complain that the mean time a doctor spends with a patient is more than 10 minutes. So the receptionist takes a random sample of 20 people and finds that the mean time the doctor spends with a patient is 11.5 minutes. So in part B we need to state our hypotheses clearly and using a 5% significance level test whether or not there is evidence to support the patient's claims. And this is for 4 marks. So essentially what the question is asking us to do is a hypothesis test with a normal distribution. So first you're going to set out our hypotheses. So we've got H0, so null hypothesis. It's going to mean that mu equals 10, so that the mean equals 10. Because what we're testing is whether the mean time the doctor spends with the patient is more than 10 minutes. So our null hypothesis is going to be, okay, so that's not true. Mean is going to be 10. So now for H1, the alternative hypothesis, we can see that mu is greater than 10. So this is the claim that we're testing. Now looking back up to part A, we wrote this distribution for x. Now because our variable x is normally distributed, we say that the average of n observations of x has the distribution x bar being normally distributed with mu, so the same mean. However, we're going to have the standard deviation squared all over n, where n is the sample size. So hopefully this will come a little bit clearer in a minute. But I'm going to use this, say, okay, so we've got x bar, it's going to be normally distributed. And here we've got mu to be 10. And here we've got the standard deviation to be 4. So you know this is going to be 4 squared, all divided by n. And n is the sample size. And if we look back up in the question, we see the receptionist taking a sample of 20 patients. So we're going to be dividing by 20 here. That's great, because we've now got a model for x bar, which is going to act as our test statistic. So quickly down here, before I forget, I'm going to write down the significance level. And they want us to do the testing. It's going to be 5%. It just says that in the question, but just so we don't forget. Great, so now we're actually going to carry out the hypothesis test. We're going to use our x bar here. We're going to say the probability of x bar. I'm going to have a look up here. We're testing the top tail of the test because we can see here it's a greater than sign. So we're going to match that sign up here. We're going to say greater than again. And what we're going to put here is the actual mean from the sample that was taken. So in real life. So in real life, when the receptionist took the sample of 20 patients, the mean time was 11.5 minutes. So we're going to put that in here. Now we can work this out in our calculator using this model here. Go into statistics mode and normal CD. We're going to have a lower value of 11.5, an upper value, and we're going to just use a large value. So I'm going to say 1,000. Then we're going to have a mu of 10. So that's our mean right here. And we're going to have a sigma. And this actually, all of this here, you need to remember that 4 squared over 20, this whole parameter here is sigma squared. So if we just want to get a sigma, so to get that, we can just simply square root both sides. So we're going to have 4, all divided by the square root of 20. It's going to equal sigma. And we're going to put that into our calculator. So we've got 4 divided by the square root of 20. And if we press equals, we're going to get 0.046766 ... And now the final stage is to compare this to our significance level. So we got this our answer. Our significance level is 5%, so we can say that 0.05 is a decimal. And our probability here is actually less than the significance level. So there is evidence to support the complaint. So I'm going to write that down a little conclusion here. So 0.468, so I rounded that to 4 decimal places, is less than 0.05, our significance level. So there is evidence to support the patient's complaint. And we get 1 mark here for our hypotheses. We get 2 marks here for both this part and this part. We get a final mark here for a correct conclusion, so something along these lines. So now I'm going to take a look at part C. It says the health centre also claims that the time a dentist spends with a patient during a routine appointment, T minutes, can be modelled by the normal distribution where T is normally distributed with a mean of 5 and a standard deviation of 3.5. And using this model, part 1 says me to find the probability that a routine appointment with the dentist takes less than 2 minutes. So writing this out instead of the words just in a mathematical way, you say, okay, so the probability of T, because that's our random variable in T minutes, we want that to be less than 2. And we want to basically evaluate that. And we're given that T is normally distributed with a mean of 5 and a standard deviation of 3.5. So if we go into statistics mode and then go into distribution and normal CD, we're going to set the lower. And because we're testing it this way around, we're going to set the lower to be a really low number. So I'm going to say minus 1,000. We're going to set the upper to be 2. And we've got mu to be 5. And the standard deviation, so sigma, to be 3.5. I'm going to press equals on our calculator. We get 0.1956 ... So we say that equals 0.196 to 3 decimal places. So that was the first part. We're now going to move on to the second part, which says we need to find the probability that T is less than 2, given that T is greater than 0. So in probability, what this line means here is essentially given that. So probability of the left-hand side, given that the right-hand side is true. Now we're given a formula for this in the formula booklet. We're given that the probability, and we're using A and B here, but that could represent anything. So we've got the probability of A, given that B, equals the probability of A and B, all over the probability of B. Okay, so we can use this formula to help us. We're just going to substitute A and B for the left-hand side and the right-hand side of this. So we're going to say, okay, so the probability, T being less than 2, given that T is greater than 0, is the probability, and the probability of T being less than 2 and T being greater than 2 is going to be the probability that T is between 0 and 2. Then all over the probability of B, so the probability of this side, so the probability that T is greater than 0. And what we now need to do is work out these different parts in the calculator. So we're going to say equals, and we're going to use the same things as last time. So if our calculator is still set up, we can just use that, using the fact that mu is 5 and sigma is 3.5. For this one in normal CD mode, we're going to set lower to be 0 and upper to be 2. So that gives us in the numerator here 0.119119 ... And that's going to be all over. And we can work this out in the calculator. So again, keeping the same values for mu and sigma. We're going to set the lower to be 0 and the upper to be a really big number, so 1,000 in this case. That gives us 0.923436 ... And it's a good idea not to round the values at this point. So if we just keep it like this and store the actual values in the calculator, that means we don't get any rounding errors. So we can divide the actual values now after storing them into the calculator. And that will give us 0.128995 ... And now, because we're at our final answer, now we can round it. So we're going to say that equals 0.129 to 3 decimal places. Now, part 3 says, hence, explain why this model for the normal distribution may not be a good model for T. So now this all comes down to what T represents. So if we look back and think of the question, a random variable T represents the time the dentist spends with a patient during a routine appointment. So the time an appointment is going to take can't be negative. It's going to have to be greater than 0. However, just homing in on the denominator here, for example, the probability that T is greater than 0, here we get that 0.923436 ... But we'd expect this to be even closer to 1, given the fact that you can't have a negative time for an appointment. This should essentially be really, really close to 1. So within this model, there's a relatively high probability of T values which are less than 0, which is impossible in the situation of the question. And this suggests to us, given the context of the question, that it wouldn't really be appropriate. That this model wouldn't really be appropriate for the situation. So I'm going to try and write that succinctly here. So the current model suggests, we say non-negligible So even though it's a relatively small proportion, it should be even less. There shouldn't really be any probability of t values less than 0, which is impossible given the situation in the question. So for this question, you get 1 mark for the first part here. You get 3 marks here for essentially going through this process to get down to the final probability. And then you get 1 mark here at the end for a reason along these sort of lines. So lastly, we're going to take a look at part D. So the dentist believes that she cannot complete a routine appointment in less than 2 minutes. She suggests a health centre should use a refined model, only including values of t being greater than 2. Part D says we need to find the median time for a routine appointment using this new model. Give me your answer correct to 1 decimal place. And this is for 5 marks. So we need to think about what the median is. So I'm going to visualise it using a line like this for a minute. And the median is essentially the halfway point in the data. So if we say here is the median, and since we think about it, when working with probability, the whole thing is going to be 1 because it's 100%. So look at the median. We can either pick above it or below it. Because we know it's halfway, the probability is going to be 0.5. So hopefully this will make a bit more sense in a minute when I write it out. So I'm going to say the probability, I'm going to use our random variable t that we've been using in the past parts as well. I'm going to say it's greater than, I'm going to say little t. And this is where little t is our value for the median. So this is the median. But we also need to remember that our model was modified a little bit since we last used it to only include values of t greater than 2. So we need to add a little bit in here. We're going to say, given that t is greater than 2. And as we explained over here, for the median, we're going to say, okay, so that's going to equal 0.5. So essentially, this is what we're working with now. And our goal is to try and work out what the value of the lowercase t here is. And that will be our median. And you should remember up here, we worked with conditional probability before. And we had this. So the probability of A given that B is the probability of A and B over the probability of B. So we're going to apply that here as well. I'm going to say the probability of t being greater than t, given that t is bigger than 2, equals the probability of the intersection between these two parts. And if we just have a think about this quickly, if here we've got the probability that t is greater than 2, but we know all values of t are going to be greater than 2 because this is our lower condition. That's what it said in the new model. We know for a fact this value of t is going to be greater than this 2 because as we explained over here, the median is halfway. So the intersection between this part and this part is just going to be this part. So we've got the probability of t being greater than t and all over the probability of this part. It's the probability of t being greater than 2. And again, that's going to equal 0.5. Now I'm going to evaluate that using the calculator. And you should remember using the model that t is normally distributed with a mean of 5 and a standard deviation of 3.5. So using that, firstly, I'm going to evaluate the denominator in the calculator. To go into normal CD mode, I'm going to set the lower to be 2 and the upper to be a large number. So in this case, I'm going to say 1,000. I'm going to set mu to be 5 and sigma to be 3.5. And in doing so, we get the probability to be 0.8043 ... If I write that, we've got the probability of t being greater than lowercase t, all divided by our 0.8043 ... equals 0.5. Now make sure to save this value in the calculator so you can keep it to as much accuracy as you can, and then we'll round it at the end. So what we're now going to do is multiply both sides by this value here. So we're going to get the probability of t being greater than lowercase t equals 0.40215 ... Now we're getting close to a point where we can work out what this value is. So we're now going to use the inverse normal function on our calculator. Now unfortunately, depending on what calculator you have, you can't necessarily evaluate this straight away like this. We need to have this sign the other way around. So we want the probability that t is less than lowercase t. So we're going to have to do 1 minus this. So 1 minus 0.40215 ... We're just going to give us 0.5978 ... So now we've done that, if we go to inverse normal mode onto the calculator, if using a graphical calculator, you need to select the left tail. However, if not, that should automatically be done by default. That's because we're testing here the left tail here. Just a side note, if you're using a graphical calculator, you could have skipped this step because it will allow you to select the right tail and do it directly with this number. Well, we're going to be using the left tail and using this line here. So we're going to set the area to be this. So our 0.5978 ... We're going to set mu to be 5 and sigma to be 3.5. And the answer the calculator gives us back will be the value for t. In this case, that's going to be t equals 5.867 ... And the question asks us to give the answer to one decimal place. So we're going to say that equals 5.9 to one decimal place. And this right here is the final answer. It is the median. So we need to see where we get the marks. We get our first mark up here for writing a statement like this. We then get another mark for writing it like this, so using the conditional probability formula. We get another mark here for rearranging it. We get a mark for this line, and then the fifth and final mark for getting down to the correct answer of 5.9.